we analyze a projectile with a known velocity at a known altitude above a level surface by first finding the x and y components of that velocity, and that's always straightforward if we know the magnitude and direction of the velocity. And then we treat the y motion completely independent of the x motion. The only thing the y motion and the x motion have in common is the time interval delta t between the firing of the projectile and its impact at the level surface down here. So the y motion, we know the initial y velocity, assuming we knew the initial magnitude and angle of the velocity. We know the y acceleration, it's just the acceleration of gravity, and we know the delta s in the y direction. From these three things, we use the equations of kinematics and we find delta t in a very straightforward manner. Although sometimes we do have to solve a quadratic, that shouldn't be any traumatic experience at this point in the course. Then, to get the x motion, the x displacement, delta sx, is just going to be the initial x velocity multiplied by the time interval delta t. This just uses the principle that the x velocity doesn't change. Now we contrast that with another situation where we know the final angular velocity, or the magnitude of the final angular velocity. And we know the altitude from which the projectile was fired, but we don't know its initial speed, and we don't know the angle at which it was fired. And in fact, we're not going to be able to find the angle at which it was fired from the information, but we will be able to find the speed. And this tells us that the angle doesn't matter. The angle doesn't have any effect on what our final velocity is, or what our final speed is. It'll have an effect on the angle at which we impact, but not on the speed. Okay, so we assume that V0 is unknown, and we use energy. Okay, we have a potential energy change because we're following a distance delta sy. We have a kinetic energy change because obviously this thing's going to speed up as it falls. From this relationship, we see that the change in kinetic energy will be the negative of the change in potential energy. Change in kinetic energy is final minus initial kinetic energy. So final minus initial equals negative potential. If we add the initial kinetic energy to both sides, we get final equals the initial kinetic energy plus the negative of the change of potential energy. Now, the change of potential energy here is whatever the mass is times acceleration of gravity times a negative delta sy, a negative displacement here. Since we're taking the negative of the potential energy, the negative of the negative displacement makes this positive, and we get this equation, which we can easily solve for V0 since we know Vf, delta sy, and g. We have only one unknown in this equation, and that's how we handle this situation.